Right now, somewhere between Mars and the Sun, a fragment of another star system is racing through the dark at more than 200,000 kilometers per hour. Astronomers call it 3IATLAS, the third known interstellar visitor ever recorded. Its trajectory is precise, but its purpose is unknown. Data from multiple observatories reveal chemical traces that don't fit the catalogs of ordinary comets. If the models hold, on December 25th, it will brush past the inner warmth of our sun before vanishing again into deep space. And before it disappears, we have one chance to learn what it truly is. Stay with me. Let's look closer. You're floating now, weightless in the quiet between planets. The light from the sun has thinned to a golden whisper, and in that whisper, something moves. A pale spark cutting across the endless dark. It isn't from here. It never was. We name it because that's what humans do when faced with mystery. 3I/ATLAS. Letters, numbers, coordinates. Our way of pretending we understand. But names are only nets we cast into the ocean of the unknown, hoping to catch meaning. The object keeps drifting, ignoring our language, obeying only the ancient grammar of gravity. The data is strange. Its spectroscopy bends in ways that make mathematicians frown. Ratios of oxygen to silicate curve against expectation. Its mass seems far too high for the light it reflects. Its coma, the hazy envelope of gas around it, is slightly off-center. A comet that forgot how to be symmetrical. Nothing impossible, just improbable. Astronomy thrives on improbability. One anomaly, and the world leans forward to listen. We've seen two such travelers before. Oumuamua, elongated like a shard of bronze, and Borisov, haloed in cyan mist. 3I/ATLAS is quieter than both, and somehow stranger. It carries itself with the gravity of something that shouldn't have happened twice, let alone 3 times. For scientists, it's a gift wrapped in uncertainty. For philosophers, it's a mirror. Because if something crosses interstellar space to arrive here, we're forced to remember how small our address really is. A single dot on the outer arm of a spiral galaxy, waiting for a knock on the door that may never come. You picture it now. The object turning slowly, its surface shedding light like dust. Each rotation takes hours. Each second brings it closer to the sun. And to us. Telescopes on Earth pivot in silence to follow it. The Hubble, the James Webb, the Very Large Telescope. All watching, all waiting. Thousands of miles apart, yet connected by a shared hunger to know what drifts above us. If it's natural, it will fade. If it's artificial, it will change everything. Either way, it will pass, and we'll be left with data, lines, numbers, wavelengths, the footprints of a mystery that barely pause to glance our way. But science, at its core, isn't about certainty. It's about paying attention, even when the universe refuses to explain itself, even when the answers feel just out of reach. So tonight, as the object races through the void, imagine you are there, somewhere between Mars and the Sun, suspended beside it. The vacuum hums softly against your suit. Below you, Earth is just a blue shimmer lost in distance. Above you, the traveler spins, silent, ancient, indifferent. You reach out, not to touch, but to understand, because understanding, like light, travels far. And sometimes it finds you long after the source is gone. Imagine you're standing in a dark observatory on a winter night. The hum of electronics replaces the sound of wind, and the only light is the quiet pulse of the telescope's tracking monitor. On its screen, a single pixel drifts slowly. That's 3I/ATLAS. It's easy to miss. In fact, most people already have. But to those who watch, that pixel holds a story written across billions of years and uncountable miles. Every object in space tells time differently. Planets move like clocks, comets like memories. They fade, return, and fade again. But 3I/ATLAS isn't from here. Its clock runs on a rhythm older than the solar system itself, the numbers describing its trajectory, eccentricity, inclination, velocity, read like a confession that it doesn't belong. It's a traveler passing through, not a resident staying to orbit. Somewhere in its motion, there's a whisper of coincidence too neat to ignore. The path it takes threads perfectly between the orbits of Mars and Earth, approaching from a direction that nearly aligns with our ecliptic plane. Statistically, it's possible, but only barely. You could watch 10,000 years of sky and never see another like it. Astronomers know this. They run simulations, thousands of them, each one assigning new random velocities, angles, perturbations, and yet the pattern keeps returning. Faint but consistent, like an echo inside a probability well. Still, probability isn't proof. In science, coincidence is just noise that hasn't been explained yet. But in philosophy, coincidence is the universe clearing its throat. They say its velocity, around 67 kilometers per second, is too fast to be gravitationally bound to our sun. That means once it leaves, it's gone forever. It will never return. Every photon bouncing off its surface now is a final conversation. Every observation, a farewell letter. At Haleakala Observatory in Hawaii, astronomers noticed the first glimmer. ATLAS, Asteroid Terrestrial Impact Last Alert System, was designed to warn us of near-Earth threats, not distant riddles. But sometimes the universe doesn't follow our filing system. A speck appeared where no known object should be. The algorithms flagged it, and the world blinked. They calculated the orbital arc, checked for parallax, ran light curve analysis. Each test confirmed the same impossible truth. The object wasn't looping around our star. It was passing through it, interstellar, like a message written in another alphabet, decoded only halfway. And so began the debate, comet or craft, natural or constructed. The word artificial makes astronomers uncomfortable. It implies intent, and intent implies intelligence. Better to call it a non-gravitational acceleration anomaly, a phrase that hides wonder inside bureaucracy. Somewhere in the silence, a telescope slews again. The motors murmur. Another image, another frame. The pixel moves just slightly more than predicted, an offset so small you could mistake it for noise. But the researchers log it anyway. Because if Oumuamua taught us anything, it's that small deviations can echo through history. The universe doesn't owe us explanations. It offers evidence, and we argue about interpretation. Still, there's a kind of beauty in that. A comet's coma, glowing faintly blue under solar wind, becomes not just ice and dust, but conversation. Between light and matter, between knowing and not knowing. And you, listening now, are part of that conversation. Every person who's ever looked up has asked the same question. What else is out there? But the real mystery is quieter. Why do we care so much? Perhaps because objects like 3I/ATLAS remind us that not everything visible belongs to us, that sometimes the most extraordinary discoveries pass through unnoticed, burning for a moment before vanishing into the archives. Thousands of interstellar travelers might have crossed before, unrecorded, unseen, because we weren't yet looking. Now we are. Outside your window tonight, the same object races through the void, untouched, indifferent. It doesn't know it's being watched. It doesn't know what it means to us. But for a brief moment in December, the story of two star systems overlaps, theirs and ours. And the line between observer and observed grows thin. Maybe that's why the astronomers stay up so late, not for certainty, but for wonder. Not for control, but for contact. However distant, however fleeting, the object moves on, the data accumulates, and somewhere between those two truths, humanity remembers what it feels like to listen. They call it the comet that shouldn't be, not because it threatens us, but because it refuses to behave. Every physical model bends slightly out of shape, when 3 IATLAS is added to the equation. Its brightness fluctuates too sharply for an object its size. Its coma expands without the expected symmetry, and its albedo, the fraction of sunlight it reflects, varies like a heartbeat, as if the surface itself were breathing. To most of the public, it's just another distant traveler, but to the scientists watching the data flow in, it's something between a puzzle and a confession. The comet's spectral lines show carbon and cyanide, yes, but also subtle deviations, faint traces that don't match the database of known interstellar volatiles. The anomaly could be noise or calibration error, or it could be something entirely new, a molecule that doesn't form under conditions we yet understand. At the observatory in Chile, a technician leans closer to the monitor. The spectrum glows like a barcode for the unknown. Each line represents a wavelength absorbed or emitted, the fingerprint of matter itself. But in 3 IATLAS, one of those lines bends ever so slightly toward the blue, a shift too consistent to be a glitch, too delicate to explain away. And so begins the argument, the great, quiet argument that fills every lab at night. Is it just an interstellar comet behaving oddly, or is it a fragment of something made? For months, the conversation has looped across conferences, encrypted emails, late-night calls. Most astronomers say natural with the calm of people who trust probability. A few whisper maybe not, their voices low, their careers on the line. Because if you even suggest design, you're no longer doing astronomy. You're trespassing into theology. But the truth doesn't care about comfort. It only waits for enough light to be measured. When the Mars Reconnaissance Orbiter aimed its high-rise camera at the object in early October, the image returned was both ordinary and unsettling. A pale smudge, a stretched nucleus, a coma offset by 50 kilometers from its theoretical center. NASA's official statement called it within natural variation. But one internal memo quietly circulating used a different phrase, consistent with rotational jetting or thin shell fragmentation. Thin shell fragmentation, a phrase so dry it hides its drama. Because if the object is hollow, then its behavior makes sense, and everything else changes. Still, even the skeptics admit that extraordinary claims need extraordinary evidence. So the search continues, methodical, careful, professional. Each pixel of data passes through algorithms, then through the hands of people who can't help but feel a small, unscientific awe. Astronomy is, after all, a discipline of waiting. Waiting for light that left its source before humans walked upright. Waiting for confirmation that might never arrive. Waiting for December when 3I/ATLAS will come closest to the sun. Perihelion, the moment when sunlight will strike its surface at just the right angle to reveal its secrets or erase them forever. You imagine that moment now, the object turning slowly, half illuminated, its coma shimmering like a ghostly veil. For an instant, every telescope on Earth and in orbit will be aimed at the same point in space. Hubble, Webb, Keck, Subaru, VLT, the entire species looking, holding its breath. And then it will pass. Maybe the readings will resolve into neat patterns, all natural, all explainable. Maybe they won't. Maybe in the fine dust of uncertainty something unclassifiable will appear, not proof, not revelation, but a question that refuses to die. That's the beauty of science. You don't chase certainty, you chase coherence. The feeling that your equations and your awe can for a moment share the same room. So tonight, when you hear the word comet, think of this one, the one that shouldn't be. Think of its crooked orbit and its shimmering asymmetry. Think of the people who stay awake for it, watching data scroll past at 2 in the morning. They're not looking for aliens. They're looking for understanding. And in doing so, they're building something stranger and more fragile than technology, a bridge made of curiosity, stretching between stars. Because in the end, That's what 3I/ATLAS really is. Not an answer, but an invitation. The radio telescopes have been listening for weeks now, quietly, endlessly, like monks repeating a mantra into the void. The Green Bank Array, the Parkes Observatory, and Breakthrough Listen's receivers all tuned to the same coordinates, the same narrow band where a whisper, if it ever existed, might pass unnoticed through the static of the cosmos. But so far there is nothing, silence perfect and absolute. It's tempting to call that silence an answer, but in science, silence means only that your instruments haven't learned to ask the right question yet. Still, that nothingness is strangely comforting. It hums like background radiation, constant, neutral, familiar. And somewhere inside that quiet, humanity listens harder than it has in centuries. Because when something crosses into our solar system from another star, the ancient reflex wakes up. Are we alone? The irony is that even if someone were trying to speak to us, across millions of years through cosmic dust and plasma, the signal might not sound like a voice at all. It could be a modulation, a shift in polarization, a rhythm buried in the noise. To recognize it, we'd need to already know how to listen. Avi Loeb, the astrophysicist who first proposed that Oumuamua might be artificial, once said that the greatest danger in science is arrogance, the belief that what we don't expect can't exist. He called 3I/ATLAS a 5 or 6 on the anomaly scale. Not proof, but not noise either. An open question shaped like a comet. And that's the strange paradox of astronomy. The deeper we look, the less certain we become. The closer we listen, the louder the silence grows. At the Allen Telescope Array, technicians scan terabytes of data, searching for patterns, repeating frequencies, unnatural harmonics, spikes in the hydrogen line. They find nothing but static, but even static has structure. The sky is never truly empty. It only speaks in a dialect too large for us to translate. One researcher jokes that maybe the signal is already here, hiding in plain sight, in the regularity of the object's spin or the timing of its sublimation jets. Maybe, she says, it's talking in light. Everyone laughs softly, not because it's absurd, but because it's beautiful. And in that laughter you can hear what science really is, the willingness to wonder out loud. The official reports remain cautious. No artificial emissions detected. Spectra consistent with volatile release. Further monitoring required. But between the lines you can sense the tension, the delicate balance between skepticism and hope. Every observation adds another piece to a puzzle whose edges keep moving. Meanwhile, the comet, or whatever it is, keeps spinning. Each rotation flicks sunlight into space like the sweep of a slow cosmic clock. Every few hours, a faint burst of gas erupts from its surface, a flare of sublimated ice, or perhaps something else entirely. Some models suggest these jets could be steering it slightly, nudging its path without altering the mathematics enough to betray intention. Intention. Such a dangerous word in the vocabulary of physics. You picture it now. The radio dishes tilted toward the stars, their white metal gleaming under moonlight, their parabolic mouths open in prayer. Across oceans and deserts, they all face the same invisible point, listening for an echo that may never come. It's almost poetic. We point our instruments outward, but the listening happens inside. Inside the same part of us that once looked at fire and wondered where it came from. Inside the same silence that waits between heartbeat and breath. So when we say there's no signal, we're really saying we're still waiting. Waiting for proof, for pattern, for meaning. Waiting for December, when the object's brightness peaks and our instruments reach their sharpest focus. Perhaps then the silence will shift, even slightly. Perhaps it won't. Either way, the act of listening changes us. It reminds us that knowledge doesn't begin with certainty, it begins with attention. You can almost hear it now, the faint hiss of cosmic background radiation, the echo of creation itself, rippling softly through your headphones. Maybe that's the only message we were meant to receive. On October 3rd, 2025, the Mars Reconnaissance Orbiter turned its high-rise camera toward a dim, fast-moving point of light just beyond the planet's orbit. The photo that arrived at NASA's servers hours later was, at first glance, nothing more than a smear. But magnified, sharpened, filtered through algorithms that pull meaning from noise, it showed something subtle, a coma faintly off-center. Its brightest region shifted about 50 kilometers toward the sun. That misalignment became the most discussed blur in modern astronomy. A natural explanation came first, of course. Comets vent gas, jets of vapor push against them unevenly, nudging their orientation. Maybe 3I/ATLAS was spinning rapidly, its rotation causing sunlight to warm one side more than the other. But the pattern didn't quite match the models. The drift was too constant, the light too smooth. Not chaotic, not random. Deliberate, some whispered before catching themselves. NASA's public statement remained neutral, no mandatory anomaly. A phrase both cautious and poetic, as though written by someone afraid of waking the cosmos. Yet behind closed doors, the debate grew fierce. Some teams insisted the data proved a fragmenting nucleus. Others argued for an unusually thin outer shell, perhaps a crust of silicate stretched over hollow ice. One scientist compared the reflective ratio to that of a heat shield tile. Another warned that such speculation risked credibility. No one raised their voice. They didn't need to. The silence between their sentences carried its own weight. Meanwhile, observatories across Earth adjusted schedules, swapping exoplanet time for interstellar minutes. The object's albedo curve, how its brightness changed with angle, was behaving like a heartbeat. Every few hours the light dipped, then surged again. A rhythm too steady to be noise. You picture it. A tiny worldlet spinning through darkness, shedding dust and ice into a ribboned wake. The sun paints it silver. The void erases the color just as fast. Its trajectory threads a perfect parabola, mathematically beautiful, emotionally unbearable. Because everything about it says temporary. We will see it once, only once, and then never again. That's what makes December 15th feel less like an astronomical event and more like a rendezvous. Humanity has an appointment with coincidence. On that day, 1422 UTC, the object reaches perihelion, its closest brush with the sun. For a few fleeting hours, every major telescope will point at the same slice of space. Hubble in low orbit, JWST far beyond the moon, the European Southern Observatory in the Atacama, the Keck twins on Mauna Kea, all turning their mirrors toward a visitor that doesn't even know we exist. It's humbling. The combined intellect of a species, focused on a speck of light smaller than a pixel, chasing truth through vacuum. And what do we expect to find? A chemical signature? A geometric shadow? Or just confirmation that mystery still survives scientific precision? In one draft memo, never released publicly, a NASA analyst wrote a single sentence that leaked through internal chat logs. If we're wrong, at least we looked. That line, anonymous and quiet, feels truer than any press release, because science isn't built on certainty, it's built on attention, on the fragile courage to stare at the unknown without turning away. Whether 3I/A TLAS is rock or relic, accident or artifact doesn't really change the story. The story is that we noticed that, for once, the universe sent something strange, and instead of naming it and forgetting, we chose to watch it until the data blurred into wonder. So when December comes and the sky brightens slightly where no star belongs, remember this. The light you see left that object about 8 minutes ago. The questions it carries left their source billions of years before that. You, the telescopes, the scientists, all of us are part of the same act. Witnessing. Not revelation, but awareness. Not answers, but alignment. Just another observation, perhaps the most important one yet. Nights stretch long, air thins cold, and telescopes wake like ancient metal flowers turning toward the same star. But this December 2025 feels different. Between the 10th and the 20th, 3I/A TLAS will glide through its final narrow window of visibility, positioned perfectly for every major observatory on Earth and beyond. 10 days. That's all. 10 nights to gather the most complete portrait humanity will ever have of this visitor before it drifts back into the interstellar dark. The schedule reads like a symphony written in data. Hubble for optical imaging, JWST for infrared spectroscopy, the Very Large Telescope for polarimetry. And from Hawaii to Chile, arrays will measure photometric light curves, watching the object's brightness rise and fall like a pulse under glass. Each technique speaks a different dialect of truth. Optical images reveal shape, color, and rotation. Infrared spectra trace heat and surface composition. Polarization maps the dust and grain structure of its coma. Each fragment of light becomes a syllable in a story still being written. To a scientist, this is the closest thing to faith, believing that enough data will make sense of wonder. You can imagine the scene at Keck Observatory, the control room quiet except for the hum of servers. The screen shows not a glowing comet, but a pixel, flickering faintly against the black. Yet inside that single pixel lies chemistry older than our sun. Carbon, cyanide, silicates, signatures of creation written before Earth existed. When light from the object enters the spectrograph, it doesn't just show what it is, it shows what it's been through. Every molecule carries the memory of collisions, radiation, eons of cosmic drift. Some scientists compare spectroscopy to archaeology with light, each wavelength a layer, each anomaly a buried artifact. And yet the questions remain larger than the answers. Is its trajectory purely gravitational? Or does a subtle non-gravitational acceleration exist, a push too steady for random jets, too quiet for propulsion we'd recognize? Is the rotation chaotic, like a stone tossed through eternity, or stable, as if maintained by something that once cared about orientation? These aren't the fantasies of fringe thinkers. They're entries in official proposals, written in cautious language phrased as tests of hypothesis. Because even the most rational minds know that beneath the equations lies a deeper question. Could someone else have been here before us? The December campaign isn't only about this one object, it's a rehearsal, the prototype of how we'll respond to the next 10, the next 100 interstellar visitors. The Vera Rubin Observatory, now fully operational, will soon flood databases with new detections. We'll need a framework, what to observe, how to rank anomalies, when to listen, and when to let go. But for now, all of it narrows to these 10 days, this small chapter in the long story of looking. Somewhere in a dim office at the European Space Agency, a young researcher recalibrates a light curve. Her hands tremble slightly. She's been awake for 20 hours. On the screen, the brightness dips, a clean periodic signal. She frowns, runs the correction again. Still there. She marks it likely rotation artifact and saves the file. But as she turns off the monitor, she catches herself whispering a sentence she'll never include in any report. What if it's looking back? Outside, frost coats the observatory dome. The sky is so clear you could mistake it for glass. Somewhere in that clarity, 3I Atlas moves. Silent, brilliant, indifferent. By the time the sun rises, the data will be archived, processed, anonymized. A line of numbers in a cosmic census. But the meaning lingers, not in the data itself, but in the act of asking. Because science isn't just about collecting photons, it's about confronting the unknown without flinching. And when December comes, that confrontation becomes beautiful. Not revelation, not discovery. Just the quiet grace of looking deeper, together. There's a certain stillness that comes after the data starts flowing. Not silence, but focus. Screens light up in dim observatories across the world. Lines of code pulse with meaning, and in the darkness behind every monitor, a human face waits for the universe to whisper something unexpected. By December 12th, the first integrated data sets begin to arrive. Photometry, spectroscopy, polarimetry, every instrument speaking in its own accent of light. The numbers stream in like rain, billions of tiny facts that, when woven together, might become understanding. At NASA's Goddard Space Flight Center, a small team cross-checks the infrared spectrum gathered by JWST. They zoom in on a dip, a spectral trough where absorption shouldn't occur. The wavelength corresponds roughly to hydrated silicates, but the temperature curve disagrees. Could be contamination, one voice says. Could be design, another murmurs, half joking, half afraid. Across the ocean, the European Southern Observatory uploads polarization maps. The dust grains near the coma's edge reflect light in unnervingly consistent vectors, not random, not diffuse. A researcher traces the pattern with her stylus. "It's like brushed metal," she whispers, though no one else is in the room. Science thrives on doubt, yet moments like this tremble with something older: awe. You can almost hear the hum of servers cooling as petabytes of starlight are archived. The data isn't glamorous, it looks like numbers falling down a screen. But behind every number lies a photon that traveled millions of miles, bounced off something alien, and chose this moment to reach us. If you were standing outside, far from the city lights, you wouldn't see any of this. Just a clear December sky and the soft outline of Virgo low on the horizon. Somewhere in that darkness, 3I/ATLAS moves. A faint mote carrying questions older than language. We build instruments to catch its answers, but in truth, we're measuring our own curiosity. As the analysis deepens, so do the arguments. One camp insists the mass discrepancy is a computational artifact, density assumptions gone wrong. Another suspects hollow structure, a void ratio inconsistent with natural bodies. The rest refuse to speculate at all. They wait for December 15th, when geometry aligns and truth perhaps will finally resolve into clarity. At 200 hours UTC, an automated script at the Mauna Kea Observatory flags a subtle brightening, a 0.03 magnitude rise. Routine? Maybe. But the pattern repeats exactly 4 hours later. Rotation period, or something else. No one dares to say it out loud, yet every researcher feels the same low-grade wonder. What if the rhythm is deliberate? In the control room, the lead astronomer rubs her eyes and types a note into the log. Periodic outgassing consistent with rotational symmetry, or scheduled. She deletes the last 2 words before saving. Outside, dawn brushes the dome in pale gold. A technician sips coffee gone cold. Someone plays ambient music too quietly to hear. For a moment, the entire planet seems to exhale, as if it knows it's being watched from a distance of 170 million miles. The data continues to arrive. It's imperfect, incomplete, beautiful. It humbles everyone who touches it, because somewhere within those wavelengths might lie a pattern, a signal, not of language, but of intention, and if not, then at least a clearer picture of what ordinary really means. For now, there's only waiting, watching the graphs curve and the sky turn. The universe does not hurry. It never has. At 1422 UTC, 3I Atlas reaches perihelion, its nearest pass to the sun. No flare, no explosion, no spectacle. Just motion, just silence. The instruments record everything: albedo ratios, dust composition, coma polarization, the faintest ripples of radio emission. Then, as if satisfied, the object begins to recede, slipping back into the cold like a thought half remembered. Later, data analysts will argue about what they saw. Some will claim that a brief shift in reflectivity hinted at structured facets. Others will dismiss it as software interpolation. The debates will last for months. But in that exact moment, December 15th, 2025, 1422 UTC, something rare happens. The entire species is united in a single act, looking up. You can picture it. Observatories silhouetted against dawn, satellites whispering across orbital relays, people stepping outside and glancing at a sky that gives nothing away. The light from 3i Atlas arrives 8 minutes after it leaves the sun, filtered through radiation and hope. It touches every mirror, every retina, every screen, and then it's gone. We gather the photons, we measure their secrets, and we try to make meaning of them. That's all science has ever been, the art of asking questions that might never be answered. When the final data packet downloads, a small cheer rises in a control room somewhere in Hawaii. Someone claps, someone cries, someone whispers, "That's it. That's all we get." They're right. The object is already leaving us. By morning, its brightness will drop below magnitude 16. Within weeks, only the largest telescopes will still see it. Within months, it will be invisible even to those. All that remains are numbers. Tiny echoes of a December night when humanity watched the universe pass by and dared to wonder what it meant. No fireworks, no revelation, just a quiet reminder that even when nothing happens, everything changes. The night before perihelion. The object is close now. 1.9 astronomical units from Earth, sunlit ice glinting faintly across a gulf of 170 million miles. Its coma stretches 100,000 kilometers, a thin veil of vapor and dust illuminated from behind like smoke in a cathedral. Every telescope that can turn toward it is watching. Every eye that can stay awake is awake. At the Jet Propulsion Laboratory, the live telemetry feed scrolls across a dark screen. Brightness fluctuates, then steadies. Temperature readings flatten into equilibrium. A line of data, barely a blip, suggests a momentary pulse of non-gravitational acceleration. It could be nothing. It could be the most important anomaly in modern astronomy. The room is silent except for the sound of fingers on keyboards. Could be venting, someone says. Could be, another replies. But the direction's wrong. And that's the moment when science becomes something more than observation. It becomes faith. The faith that within complexity lies coherence, that reality will eventually explain itself if we listen with enough patience. Meanwhile, in Chile, dawn creeps along the Atacama Plateau. The VLT mirrors catch the first gray light. They've spent the whole night following the object's path across Virgo, gathering spectroscopic data so fine it can detect a fingerprint in a beam of starlight. The last exposure finishes just as the desert begins to glow. Someone in the control room exhales a quiet, "We got it, they don't know what it is yet." Across the world, JWST's deep field instruments begin their sequence. Infrared eyes trained on a traveler older than humanity. The detectors hum at absolute zero, recording heat that has traveled through vacuum and memory alike. The engineers call it listening to darkness. The data arrives 3 seconds later than predicted. Someone frowns. Someone else shrugs. The discrepancy is trivial, but not zero. Tiny differences matter when you're measuring perfection. You can almost feel the collective heartbeat of the planet synchronized to this one act of attention. From Tokyo to Pasadena, from Delhi to Geneva, every researcher knows the next 24 hours will decide which history book this story belongs to. The one about comets or the one about contact. And still, the sky remains calm. The night after perihelion feels different, quieter, emptier, as if the sky itself has exhaled. The telescopes are still pointed toward the same coordinates, but now the object has begun to fade. Its light, once crisp, now softens into the static haze of distance. 3i Atlas is leaving us. In the control rooms, monitors dim one by one. Scientists lean back in their chairs, shoulders slumping under the weight of exhaustion and awe. Weeks of vigilance have come down to this: 1,000 terabytes of numbers, spectra, curves, and graphs, the residue of wonder translated into data. And what does the data say? Nothing definitive yet, only hints. Thermal signatures that don't quite match composition. Structural patterns that suggest regularity but refuse confirmation. Enough to provoke fascination, never enough to prove. A senior researcher writes in her log, "Nothing extraordinary confirmed, nothing ordinary either." The paradox defines the mood. In the halls of observatories and the quiet offices of universities, humanity begins the long process of interpretation. The glow of the object may be gone, but the afterglow of curiosity lingers, a kind of scientific afterimage. Papers are drafted, simulations rerun, models adjusted. Everywhere, a single sentence echoes, "We need more data, but there won't be more." 3 I Atlas is receding at 67 kilometers per second. In a few weeks, it will be past Jupiter's orbit, its light too faint even for the largest mirrors. Every question left unanswered will remain that way, perhaps forever. Still, the debates grow louder. Some astrophysicists insist it was a natural comet with unique structural stresses. Others argue for the possibility of artificial geometry, the symmetry of its coma, the persistence of its thermal readings, the exactness of its albedo curve. A small minority call for humility. We don't know what's out there. We only know what we're capable of seeing. And maybe that's the truest line in all of science. In a sense, the story of 3I/ATLAS isn't about the object itself. It's about the limits of perception. Every observation is filtered through human expectation. Every anomaly wrestled into the language of probability. We call it analysis, but it's also confession. The cosmos presents us with a mirror, and we see only what our minds can tolerate. By the morning of December 16th, 3I/ATLAS has already begun to fade beyond the reach of most instruments. Yet what it leaves behind is not emptiness, it's a silence filled with interpretation. Inside research centers, the glow of monitors never dims. Thousands of terabytes are being cleaned, corrected, recalibrated. Spectral noise is filtered, thermal plots are overlaid, orbital models are run 1,000 times with 1,000 slightly different assumptions. Every variation is a prayer to probability. Tell us what we missed. But astronomy is slow by nature. There are no breakthroughs in real time, only patience and the faint satisfaction of knowing that the light we've already captured is still revealing itself, photon by photon. Weeks will pass before preliminary results emerge, months before peer review, years before consensus. Yet among the analysts, something quieter happens. Reflection. Because what they have witnessed is not only a celestial event, but a test of method, of how humanity reacts when faced with an object that sits precisely at the edge of explanation. Was it a comet? Almost certainly. Was it something more? Possibly. But the true question may be simpler. Would we even recognize the difference if we saw it? At a press briefing, a journalist asks whether the December observations revealed anything new. A senior astronomer smiles faintly and replies, "Everything was new. We just don't know which part of it matters yet." The room laughs softly, but there's an undertone of truth in it. Science rarely ends with exclamation points. It ends with ellipses. Meanwhile, public interest begins to swell. Online forums fill with speculation. Artists post imagined renderings. Conspiracy channels whisper of engineered probes. And buried beneath all of it, genuine curiosity blooms. For every 1,000 fanciful theories, there is one person who looks up and simply wonders. Maybe that's how discovery really begins, not with certainty, but with wonder refined by discipline. Somewhere in the archives, an intern scrolls through raw telescope data, frame after frame of darkness dotted with a single moving light. Each image separated by minutes, each shift in position a subtle reminder of cosmic motion. He zooms in, adjusts the contrast, and for a moment imagines he can feel the object moving, not as numbers, but as presence. He leans back, smiles, and types in the observation log, "Still moving, still beautiful." That note will never appear in any publication, but it captures something essential. Because 3I/ATLAS isn't just a scientific case study, it's a mirror held up to human nature. We analyze, categorize, debate, and yet, when faced with the vastness of the unknown, our first impulse is still to watch in silence. Soon the object will be beyond reach, joining Oumuamua and 2I/Borisov in the quiet catalogue of interstellar travelers. But its meaning will stay here in the people who measured, doubted, and dreamed. Maybe that's the real legacy of December 2025. Not answers written in equations, but questions etched into memory. After all, the universe doesn't owe us revelation. It only offers opportunity, the brief flicker of comprehension before mystery closes again. We took that chance. We looked. And for a moment, we listened. The headlines fade within days. A few science outlets summarize the event. Interstellar Object 3, I/ATLAS, makes closest approach. Data pending. Then the world moves on. Holidays arrive, the news cycle shifts, and only the astronomers remain awake, sifting through the silence. It's strange how quickly humanity can forget that something once passed through its sky from another star. We've learned to live beside the extraordinary, to catalog it, archive it, and let it go. But for the people who watch 3I/ATLAS vanish, forgetting isn't an option. In laboratories from Maryland to Munich, small groups still stare at screens, comparing one December curve to another. See here, a technician says, pointing to a cluster of residuals. That deviation shouldn't exist. Her supervisor nods, tired but intrigued. The deviation remains even after corrections. It's small, infinitesimal perhaps, but consistent. And consistency is where truth begins. Elsewhere in Cambridge, a philosopher of science prepares a lecture on the cost of certainty. He begins with an image of 3I/ATLAS and says softly to his students, "The danger isn't that we're wrong about the universe. The danger is that we stop asking what it's trying to tell us." Because by now the object is nearly gone. Its velocity has carried it past the plane of Mars, accelerating gently outward, free of sunlight's heat. In another month, it will cross Jupiter's orbit. In another year, it will be a cold idea in a warmer sky. Yet its story is still expanding. Each anomaly, thermal, spectral, orbital, branches into new theories. Some plausible, some poetic. A paper quietly circulating through archives proposes a model, a hollow shell of refractory material, possibly a relic of engineered debris. The conclusion reads, "While no evidence confirms artificial origin, such hypotheses should not be excluded from statistical consideration." It's cautious language, but history remembers sentences like these. They sound neutral when written, but prophetic when rediscovered decades later. Still, most scientists remain unconvinced. Extraordinary claims require extraordinary evidence, they remind each other. And evidence, like starlight, fades fast. Outside academia, the object acquires myth. Documentaries call it the visitor that almost spoke. Artists imagine it as a drifting cathedral, a seed, a silent machine still humming under cosmic frost. And in a way, each version is true. Because mythology isn't a rejection of science, it's the echo of its questions. You sit beneath your own December sky and try to imagine the object still moving out there, past Saturn now, perhaps. Invisible but not gone. Every second it travels another 67 kilometers farther from everything that once tried to understand it. And yet, somehow, you feel closer to it than ever. Because the act of searching leaves an imprint. The same way a telescope's mirror records the ghost of every photon that touched it, curiosity leaves a residue in those who dare to look. Maybe that's the quiet gift of 3I/ATLAS. It didn't give us answers, it gave us permission to doubt more deeply, to wonder more precisely. When the last data set is archived and the funding shifts to other missions, a few researchers will still check the tracking software at night. They'll scroll through orbital projections, knowing the numbers are now almost meaningless. Still, one of them will whisper, "Goodbye, traveler." The stars won't answer. They never do. But the silence will sound a little different. Not empty, but aware. The world forgets, but the data does not. Inside the servers of observatories scattered across the planet, the light of 3I/ATLAS still waits to be interpreted. Every photon that struck a sensor last December carries a small confession of what the universe was willing to show us. The scientists begin to reopen the files. It's spring now. The long nights have ended. Yet the story that began in darkness continues quietly in the light. At the Jet Propulsion Laboratory, a small team runs comparative models. They feed Atlas's brightness data through updated algorithms, testing for rotational irregularities. One graph spikes where none should. A tumbling nucleus, someone suggests. Another shakes her head. Too consistent for a tumble. Across the ocean in Chile, a telescope captures its final trace. A faint glimmer near the edge of visibility, a goodbye in spectral form. The data file is less than 3 kilobytes, but it becomes the most studied piece of information of the entire mission. Every scientist knows the truth. The more the data fades, the deeper its mystery becomes. And so the papers begin again. This time, the language grows more careful. Statistical anomaly, non-standard reflectance behavior, persistent thermal offset. Words arranged like fences around what cannot yet be said. The pattern, they realize, resembles something else. A whisper of geometry beneath the randomness, a kind of intention hiding inside chaos. It could still be natural, one astronomer insists, just highly unusual. Another replies, or it could be what unusual looks like when we're not ready for the alternative. This tension between safety and possibility has become the heartbeat of modern science. We want to know, but not too much. We want to believe, but not appear foolish for believing. And so the story of 3I/ATLAS settles into that gray space between skepticism and awe. Meanwhile, philosophers of science write essays titled "The Pattern We Might Be Missing." They remind us that every great discovery began as an error someone refused to ignore. They quote Galileo, Newton, Sagan, voices who understood that knowledge is less about answers and more about the courage to ask again after being wrong. Late one night, an astronomer walks out of the control room, the screens still glowing behind her. She looks up at the same sky she studied for 20 years. It's quiet, familiar, infinite. Somewhere beyond those constellations, Atlas continues on its trajectory, past Jupiter's orbit, slipping toward interstellar darkness once more. She whispers, almost to herself, "If it was just a rock, it was a beautiful one." There's a pause, then softer. "And if it wasn't, we'll see." That's the truth of it. We will see, someday. Maybe not with this generation of telescopes, maybe not even with this civilization. But the universe keeps receipts. The data we gather today will still speak long after we're gone, whispering to whoever comes next. They looked, they wondered, they tried. 3I/ATLAS has already crossed the orbit of Jupiter now. In 6 months, it will pass into the outer dark where sunlight is weak and memory weaker still. Its temperature will fall toward absolute zero. The gases that once vented faintly from its surface will freeze solid again, locking whatever secrets lie beneath in perfect eternal silence. But silence is not the same as absence. Somewhere, a tiny thread of light still reflects from its surface, a signal too faint for our instruments but still racing outward wave by wave toward the distant stars. And perhaps somewhere else, another civilization will see that faint glint and ask the same question we did. What was that? In that moment, across the gulf of light years, humanity's curiosity will be reflected back to us. Proof that even in the vast cold dark, wonder travels farther than anything we've ever built. By midsummer 2026, the story of 3I/ATLAS has folded into scientific folklore, not because it revealed something final, but because it refused to. In conference halls and late-night lab chats, people still begin sentences with, "Remember ATLAS." The tone is always the same, part nostalgia, part unfinished thought. No one says it aloud, but they all know the mystery has become more valuable than any answer ever could be. The Vera Rubin Observatory begins its full sky survey that year. Its mirrors sweep the heavens every few nights, capturing terabytes of starlight. The algorithms hum quietly, searching for movement, small shifts in pixels that might signal another visitor. And one evening, the system flags an anomaly, a faint, slow streak arcing against the background stars. It's not Atlas, of course. It's something else. But the mood in the control room changes immediately. Hope feels different after you've already met the impossible once. Even if this new object proves ordinary, it won't matter. Because 3I/A TLAS taught us to look closer, to imagine that the improbable could still be instructive, that coincidence can disguise pattern, that the universe doesn't repeat, but it does rhyme. Back on Earth, the public slowly rediscovers the story. A streaming documentary titled The Visitor Between Worlds gains quiet popularity. It blends archival telescope footage with calm narration, soft string music, and a simple closing line. We did not find proof of another civilization, but we proved we were ready to ask. That's what makes this story linger. Its lack of closure becomes the point. In classrooms, teachers tell students about the event not as a warning or triumph, but as a meditation on how discovery truly works. Knowledge, they say, is not a possession. It's an attitude. And in a way, 3I/ATLAS has become a character, the quiet protagonist of a new myth. A reminder that the cosmos doesn't owe us clarity, it offers conversation, one we can join only by listening. Late one night at an observatory in the Canary Islands, a young astrophysicist replays the 15th of December data for the 1000th time. He aligns each plot, adjusts the filters, enhances the faint signatures until a single curve emerges. Subtle, elegant, perfectly consistent with nothing. He exhales, smiling. "Still there," he whispers. Outside, the air is cool. The Milky Way stretches across the sky like frost. Somewhere beyond it, Atlas keeps going, a speck of memory moving through darkness at 67 kilometers per second. It will outlive every telescope that ever tracked it, every civilization that ever wondered what it was. But here, beneath the stars, a single human being still cares enough to check. And that, perhaps, is the real equation of meaning. Curiosity divided by time equals legacy. Because science isn't about certainty, it's about devotion, about the long faith that truth exists, even if we never get to hold it. So the data stays stored, triple backed up in cold servers, waiting for better eyes to look again. The orbit logs are archived, the models are frozen, but the story breathes on. Astronomers often say there's comfort in precision, in knowing the decimal that defines a planet's distance or a comet's speed. Yet what 3I/ATLAS gave us was something rarer, the humility to accept unmeasurable beauty. Because sometimes the universe doesn't send answers, it sends visitors. They arrive, they pass, they vanish, and we are changed simply because we noticed. You sit with the numbers again, the way you sit with an old song, the melody familiar, the meaning new each time. The plots from December are quiet now. No more live feeds, no more breathless refresh. Just you, a screen, and a traveler already far beyond Jupiter's slow halo. And the question you can't put down, what if we're wrong? If it's natural and we doubted too much, nothing breaks. We adjust a model, tune a prior, file the anomaly under rare but real, and move on. If it's artificial and we doubted too little, Still, nothing breaks, except perhaps our reputation at faculty lunches. But if it's artificial and we dismissed it, then the cost is harder to price. A once-in-a-civilization encounter mistaken for a pretty comet. Not doom, not drama, just the ache of a door we didn't try. You weigh those errors the way a pilot weighs crosswinds. Left or right, both are wind. But one lands you short of the runway. Science has always balanced on that knife edge. When pulsars were discovered in 1967, their uncannily regular beats were tagged, half-jokingly, LGM1, Little Green Men. A month later, the joke evaporated. Neutron stars, not neighbors. A mainstream historical fact, filed and certain. Yet the cautionary note remains. The universe loves to present the extraordinary in ordinary clothing, and we love to read meaning into noise. It's a win-win, except for our sleep schedules. So what if we're wrong about 3 IATLAS? You walk the two paths. If it's natural, the lesson is mercy. Improbable geometry still happens. Perihelion timing can be coincidence dressed in statistics. Thermal signatures can wobble without intent. We update our priors, widen the scatter bars, and remember that comets are complicated, like weather and people and committee meetings that somehow last longer than a Martian year. Truly, nothing outpaces a budget review. We learn, again, that humility isn't just a virtue, it's a method. If it's artificial and we miss it, the lesson is heavier. Not cinematic, not apocalyptic, just the slow dawning that we were the punchline to our own caution. The cosmos sent a riddle. We graded it as a typo. You think about the asymmetry. A false positive costs time. A false negative costs history. Not revelation, but regret. Not catastrophe, but a smaller version of ourselves than we needed to be. Of course, this is where philosophy sneaks in wearing a lab coat. What counts as recognition? A narrow-band radio spike? A geometric facet in the coma? A trajectory tweak at perihelion with no thermal budget to justify it? There's a sliding scale between probably ice and please call everyone. And somewhere on that scale, institutions begin to drag. Bureaucracy moves slower than comets. That's not criticism, just Newton's third law of funding. You scroll up to the line in your notes, the one you typed at 2 in the morning during the window. Not extraordinary confirmed. Not ordinary either. You smile. It still fits. History offers a quirky mirror. During Halley's Comet in 1910, newspapers shouted about cyanogen in the tail. People bought anti-comet pills and bottled comet-proof elixir, which was mostly colored water and confidence. The placebo effect, but make it celestial. Historians still argue whether the panic was media theater or a clever ploy by opportunistic chemists with very shiny labels. Either way, the lesson sticks. Our stories about comets can matter more than comets themselves. Which brings you to December. Our story this time was gentler. No panic, no pills, only attention. A planet-wide act of listening. If we erred on the side of wonder. There are worse sins. You imagine a small meeting room, a handful of tired scientists, 2 policy people, 1 overstretched communications officer. On the screen, a slide titled Post-Perihelion Summary. Bullets march down the page. Non-gravitational acceleration signal to noise low. Spectroscopic residuals remain inconclusive. Polarization vectors suggest grain alignment beyond typical A-hand rises. So what do we say? Another hand. We say we're still looking. A third, and we mean it. Meanwhile, the public narrative drifts toward its own poetry. Artists render the object as a sleeping cathedral. Essayists describe it as a mirror held to our doubt. A late-night host jokes that if aliens came this close, they clearly saw our social media and kept going. Light joke number 1, your smile is small, but real. None of it is data. All of it is truth of another kind. You return to the plots, the periodic light curve dip, the thermal plateau that shouldn't be a plateau, the coma offset that's within error bars, and somehow outside your boundaries of feeling. Astrophysicists still argue whether Oumuamua's acceleration was exotic outgassing or sunlight pressure on an odd shape. The same voices now debate Atlas's thin shell hypothesis. The language is careful, the stakes quiet, the implications obvious. So what do we do with the possibility that we're wrong? First, we institutionalize attention. A standing interstellar rapid response protocol. Pre-allocated telescope time across the spectrum. A triage scale that promotes unusual trajectories, suspect spectra, and perihelion timing that hides maneuvers in solar glare. Fewer memos after the moment, more instruments during it. Second, we expand our listening. Radio, yes, but also polarization rhythms, thermal cadence, dust grain alignment drift, the choreography of jets. Intention, if it exists, may never sound like a voice. It may look like coherence where randomness should reign. Light joke number 2. If aliens send a friend request, it probably won't arrive as a push notification. Check your polarization inbox. Third, we accept uncertainty as a public good. Tell people calmly, we don't know yet. Tell them again. Let wonder and honesty be the same sentence. The universe did not sign our consent form for clean narratives. Light joke number 3. It also ignored our unsubscribe link. And then we practice the oldest discipline in astronomy. We wait, not passively, patiently. You think of Voyager's golden record, now farther away than Atlas will be for a very long time. That copper memory spins in a darkness so deep that distance becomes metaphor. The record may never be played, but it means something that we sent it. It means something that we looked at Atlas and chose as a species to spend our best nights paying attention. If we are wrong on either side, the echo will last longer than the object's orbit. It will surface in new funding lines, in revised coursework, in a teenager's decision to study spectroscopy because one December the adults looked up and admitted they didn't know. Somewhere beyond the planets, the object turns its unhurried face to colder light. Your screen dims to sleep, a small simulation of heat death. You breathe, and the room answers with its familiar hum. Not revelation, but data. Not answers, but understanding. Patient, incremental, humble. You whisper a sentence that feels like both apology and blessing. If you were only a comet, thank you for the lesson. If you were more, thank you for the mercy of mystery. Either way, the cosmos keeps moving. Either way, we keep listening. We don't know. We can't know. But we still look. By autumn, even the word Atlas feels ghost-like, something you once heard in a dream. The object itself is gone, a faint arc now lost in the black geometry of deep space. But its echo lingers, not in the sky, but in language. Every time someone says interstellar, object, trajectory, they unconsciously carry its dust forward. And in that persistence, meaning accumulates. The final reports arrive one by one. No conclusive evidence of non-gravitational acceleration. Spectral variance likely due to mixed volatiles. Reflectivity inconsistent but within model tolerance. Each line a soft verdict of ordinariness. Each sentence an attempt to fold the extraordinary back into the rules. Yet, something resists. A margin note here, a cautious phrase there. Words like possibly, uncharacteristic, further study warranted. Science, at its most honest, never fully closes a file. In the years to come, the data of 3IATLAS will be reanalyzed with sharper instruments and more patient minds. Someone will find an unexplained asymmetry. Another will smooth it away with a better equation. The debate will flicker and fade as all debates do. But beneath it runs a deeper current, an unspoken recognition that we were alive to witness a question too large for its moment. And that, perhaps, is enough. Because every measurement, every calibration, every sleepless night under fluorescent light was an act of reverence. To look at a moving point of light and wonder who or what set it free. A century from now, another traveler may appear. 1,000 more will follow. Some will be ice, some stone, some signals. Most will pass unnoticed. But maybe one someday will linger. Maybe it will slow down. Maybe it will answer. Until then, we are keepers of the silence, observers of the dark between stars, the patient species that asks again and again, what if? So tonight, let the noise of daylight fade. Let the last question dissolve into the hum of your own breathing. The object is gone, but its lesson remains. Not revelation, but data. Not certainty, but care. Not proof, but attention. The universe doesn't explain itself. It only offers you the chance to listen once closely before the sound disappears. Close your eyes now. Imagine that far away a small shard of another world drifts through starlight older than language, carrying nothing but silence and the faint memory of being seen. Sleep and let it pass. The light is fading now. You've traveled across orbits and theories, through equations and echoes, all for a single fleeting visitor. And maybe that's the truth behind every cosmic story. We chase what's already leaving. The stars outside don't hurry. Their light travels for ages to find you, brushing softly against your closed eyes, whispering that time is not a line, but a tide. It rises, falls, and carries everything forward, including you. Remember this, the same atoms that built 3I Atlas built you too. The calcium in your bones, the carbon in your breath, the iron in your blood, all once forged in the same kind of furnace that gave birth to that traveler. The difference between you and the comet is only intention. You move because you wonder. You seek because you hope. So breathe. Feel the air as a form of gravity, keeping you here, grounded on a small blue world that dares to ask questions of the stars. The object will keep moving long after every telescope shuts down. But the story it left, the one you now carry, will continue inside you in the part of your mind that stays awake even as you sleep. Let it settle there, like dust from another sun. And when you wake, remember, the universe is still speaking, quietly, patiently, through the hum of circuits, through the shimmer of data, through every breath of light that reaches this fragile place. Listen again. The next traveler is already on its way. End of script. Sweet dreams.